Alright, so first let us solve some divisibility questions, then we will go to geometry, and then Anaga has said complex numbers, but she herself is absent today. Let's see. Okay, we will start with this question. This is from Nest 19 first shift, question number 9. It says a positive integer k is perfect if the sum of its positive divisors equals 2k. Okay, if n is a perfect number, then the sum of the reciprocal of its positive divisors varies with n, is 2, is 1, is greater than n by 2. Alright, first of all, let's try to understand what is positive integer. Positive integer is a natural number. Okay, and what is meant by a divisor? Well, in school days we would call divisor as a factor, something which divides it perfectly and leaves remainder 0. Now it is said that a positive integer k is perfect if the sum of its positive divisors equals 2k. If n is a perfect number, then the sum of the reciprocal of its positive divisors. Okay, now one thing that we would like to note here is this. Okay, suppose n is any natural number. Okay, suppose n is any natural number. Okay, and if d1 is one of its divisors, okay, if d1 is one of its divisors, then if you write n as d1 into d2, because d1 is a divisor, d2 will also be a divisor, right? So observing this, we can solve the problem, right? If d1 is a divisor, then so is d2. If d2 is, then so is d. Alright, now let us say that n is our perfect number. Okay, let n be perfect, and this is actually a term. Okay, it's not that they've come up with a random word here. Okay, if you Google it, or even this has a Wikipedia page, what are perfect numbers, and the definition in the first statement is indeed the definition of perfect number. Okay, and let us suppose that the divisors are d1, d2, d3 up to dm. Okay, now if we arrange these divisors in ascending order, okay, suppose we arrange these divisors in ascending order, then do you agree that d1 will be 1 and dm will be n? सबसे छोटा 1 होगा, सबसे बड़ा वही नंबर हो जाएगा. Have you followed this?
Yes, sir.
Now we are not sure about d2 very much, okay, whether it will be odd or even, whether it will be 2 or not, and I'll also tell you a few interesting things later about this simple looking problem. ठीक है, तो अभी कंडीशन क्या है? सम ऑफ इट्स पॉजिटिव डिवाइजर्स इक्वल्स 2k. ठीक है, तो यहाँ पे क्या हो गया? d1 plus d2 plus d3 plus d4, let us say, up to dm, this is equal to 2n. अब ये क्यों आया? क्योंकि वो परफेक्ट है. ओके, और परफेक्ट का सम होता है 2k. ठीक है, cool. Now what they have asked us is they want us to determine the sum of the reciprocals of its positive divisors. Now how can we find the sum here of the reciprocals? Look, the trick is this. At first when we began solving this problem, हमने कहा कि अगर d1 फैक्टर है तो d2 भी फैक्टर हो जाएगा, है ना? तो अगर हम लोग इस पूरे इक्वेशन को n से डिवाइड करते हैं, ये इम्पोर्टेंट है. ओके, की स्टेप. डिवाइडिंग बाय n, क्या मिलेगा? 1 d1 by n plus d2 by n plus d3 by n plus d4 by n. कब तक? dm by n तक equals 2. अब ये थोड़ा promising लग रहा है because in the option it is there is 2, but we have to arrive at the right conclusion. Now look, because of this, when we divide any factor or divisor of a number by the number itself, we are guaranteed to get reciprocal of some other factor. Do you agree? If we divide any factor of a number by the number itself, we will always get reciprocal of some factor of the number. अगर वो perfect square है तो वही number का reciprocal आएगा, okay, of some factor of the same number. Raise your hands if you understand this. Okay, great. Which means, so in this case if we arrange them in the ascending order and then add, तो d1 upon n का partner है dm upon n, है ना, और बाकी के सभी वैसे हो जाएंगे. Therefore what we can say is summation, okay, let's say dm, or let's say dj by n, as j goes from 1 to m, is actually equal to summation as j goes from 1 to m 1 upon dj, and that is actually 2. Now the second thing here is important क्योंकि ये इससे follow कर रहा है. Okay, what we made use of is this. We already knew that this sum is 2, तो पता ही है हम लोग को, है ना. But what we have said is अगर कोई फैक्टर को उसी नंबर से हम डिवाइड करेंगे तो हमें जो नया नंबर मिलेगा वो किसी दूसरे फैक्टर का ही रेसिप्रोकल होगा, एंड we have written that here, okay, and therefore the answer is 2. Okay, therefore the answer is 2. Now this is a trick based problem, and usually these tricks, or rather this topic called number theory, is not a part of our curriculum, लेकिन नेक्स्ट में ऐसे क्वेश्चंस पूछते हैं. Now this is all fine. I would like to discuss one more approach. Okay, तो इसको हम approach 1 कहेंगे. Now in approach 2, what we do is we go for trial and error method. Okay, and if you know a bit of course this is time consuming because this is trial and error, तो अगर पता है तो आपको जल्दी आ जाएगा उसका आंसर. So the thing is, the first such number, which is not too difficult to find, is 6. Okay, the first such number is 6, which has factors 1, 2, 3 and 6. And if you add these, you will get 12, which is 2 times 6. Okay, so that meets all the requirements for to be a perfect number. अगर हम इसके फैक्टर्स का रेसिप्रोकल लेके उनका एडिशन लेंगे, 1 plus 1 by 2 plus 1 by 3 plus 1 by 6, LCM 6, तो ये 6 हो गया, ये 3 हो गया, ये 2 हो गया, ये 1 हो गया. ठीक है, so that's indeed 2. Now if it is equal to 2, कोई हम ऑप्शंस रूल आउट कर सकते हैं क्या? is 1 तो हो गया, is greater than n by 2 भी नहीं आएगा. क्यों? Because n itself is 6, so n by 2 will be 3, and the sum that we have got is less than that, so it's 2. Okay, so it is either A or B now, है ना. C और D नहीं आएंगे. तो फिर A और B में से कैसे डिसाइड करेंगे वेरीज विथ n है या is 2? तो इसके लिए हमें और एक एग्जांपल लगेगा. we'll need one more example. and that's why I said it's a bit time consuming. The second such perfect number is 28. Okay, let's try to see if we can factorize it. So 1, 2, 4, 7, 14 and 28. अब हम ये चेक कर सकते हैं 1 plus 2 3, 3 plus 4 7, 7 plus 7 14, 14 plus 14 28, and then so that's indeed the sum is indeed 56. And if we now go for the sum of the reciprocals, आपको वो समझ में आ जाएगा क्योंकि अगर सम 2 into 28 है तो डिवाइड करेंगे तो वही फैक्टर्स आ रहे हैं. ओके, 1/4 plus 1/7 plus 1/14 plus 1/28. The moment you get this as2, the dependence on n is gone. Okay, 1 plus 1/4, 1/2 plus 1/4 plus 1/7 plus 1/14 plus 1/28 expecting 2 आ गया. Okay, so by doing this the dependence on n is gone, so the correct option is 2, because for two different examples we have got the sum of reciprocals is 2. Now you'll be surprised, okay, there was a similar question, almost same, okay, as almost identical to 19.1 question 9, and this sum came in NEST 2021 shift 2 question 11. अब आप ये पढ़ो और आप बताओ कि क्या उसका आंसर है. Let d1 d2 d3 up to dr be all the positive divisors of n. If d1 plus d2 up to dr is 1000, then 1 upon d1 plus 1 upon d2 up to 1 upon dr equals. What will be the answer? Correct, the answer is A. तो क्या करना है, वही डिवाइड बाय तो डिवाइड बाय n करेंगे तो क्या आएगा, d1 by n plus d2 by n plus dr by n is equal to 1000 by n. Now ये जो हमने यहाँ पे लिखा है we need to use it again, है ना. What is it? If we divide any factor of a number by a number itself, we will always get reciprocal of some other factor of the same number. Got it? In other words, if our number is n, okay, and let its divisors be, let's say, ti into dj, अगर हम di को n से डिवाइड करेंगे तो हमें 1 upon dj मिलेगा. So okay, so this second problem or this problem in NEST 21, this is actually more explicit, okay, क्योंकि वो बोल रहा है हमें कि क्या एक्सप्रेशन निकालना है, मतलब ऑप्शंस भी वैसे explicit है, okay, A B C D 1000 upon n 1000 upon n squared और ऐसे. Is it clear? Yes?
Yes.
Yes sir.
समझ गया ना? Okay. ठीक है, तो ये दोनों क्वेश्चन को एक ही बोल सकते हैं क्योंकि दोनों लगभग सेम ही थे. Okay, now this is actually a permutations and combinations problem, and this is a standard type in competitive exams. The number of from NEST 20 second shift, the number of positive divisors of the number 79200 which are not divisible by 4 is 436 1872. कैसे करेंगे इसको? First of all we must factorize this, है ना. Okay, 100 तो है. Okay, 396. It's not divisible by 8, but it's divisible by 4. So it's 2 raised to 3. Oh wait, not 2 raised to 3. 100 is 25 into 4. Okay. Okay, so 2 raised to 5. 2 raised to 5, है ना, into 3 raised to 2, okay, into 5 squared into 11. Okay, it's correct. Now, suppose I ask you to tell me total number of devices. अब ये ट्रिक शायद आपको पता होगी. Does anyone know that trick? How to decide the total number of divisors? Look.
Sir, 10.
10?
10.
नहीं ज़्यादा है. See, look. Any divisor of 79200 will be of the form 2 raised to m1, 3 raised to m2, 5 raised to m3 and 11 raised to m4. ये तो समझ में आ गया. 2 raised to m1, 3 raised to m2, 5 raised to m3 into 11 raised to m4, है ना. Now m1 can be any number from 0 to 5. Okay, m1 can be any number from 0 to 5. तो m1 के 6 वैल्यूज पॉसिबल है. एंड फॉर m2 इट कैन बी एनी नंबर बिटवीन 0 एंड 2. तो इसके 3 वैल्यूज पॉसिबल है. m3 again 0 1 2, so 3 values possible. And for m4 it can't be greater than 2 or even equal to 2. It has to be 0 or 1, है ना. तो 2 हो गया. So total number of divisors, how many are there? 6 into 3 into 3 into 2, multiplication principle. Okay, so 108. Have you understood this or not? ये समझ गया?
Yes.
Yes, sir.
Okay, so this is a general question of finding the total number of divisors. और ये आईसर में एक बार आया था, मुझे अभी याद नहीं है एग्जैक्ट ईयर, लेकिन आईआईटी में एक बार ऐसा आया था कि इसके नंबर ऑफ डिवाइजर्स कितने. एक्चुअली एप्टीट्यूड का क्वेश्चन है. ठीक है, तो अभी हम लोगों को उन्होंने पूछा है कि नंबर ऑफ पॉजिटिव डिवाइजर्स ऑफ द नंबर 79200 विच आर नॉट डिविजिबल बाय 4. नाउ प्लीज लुक, नॉट डिविजिबल बाय 4 मीन्स कैन बी डिविजिबल बाय 2 but should not be divisible by 2 raised to 2 and beyond. Got it? Which means, look, if I were to write a factor or the general form of factor of 79200 sorry not divisible by 4. So I can again write it in this form, but only change that I will make is I will restrict m1 exceed exceeding from 1, है ना. m1 cannot be greater than 1. ये समझ में आ गया? क्योंकि अगर वो m1 1 से बड़ा हो गया तो 2 हो जाएगा, तो 4 हो जाएगा. It will become divisible. Have you followed this? Yes?
Yes, sir.
Yes.
तो अभी whatever factors that are there for 3, 5 and 11, they will still be there. So there will not be any change in this number. But for m1, now we have only 2 possible values. m1 can either be 0 or 1, so 2. So the correct answer is 36. Is it clear? Yes? It's 36. Now they can also ask you this question as a probability question. What will that be? Probability that a randomly chosen factor is not divisible by 4? तो कितना आएगा उसका? 36/10.
36.10.
Okay. Probability that it is not divisible by 4, given that it is an even number, कितना आएगा? The factor is even but not divisible by 4. Yes. Yes, what happened? What is the probability that the factor is not divisible by 4 under the condition that the factor is an even number?
0, sir.
0 कैसे रे? 2 ले लो, नॉट डिविजिबल बाय 4 है लेकिन इवन नंबर है ना, तो कैसे 0 हो गया प्रोबेबिलिटी? Anaga, what were you saying?
0.3.
0.3 or 1/3, is it? How did you find it?
So basically, if it is even, there has to be at least one power of 2.
Correct.
So for the total number of possible outcomes, we have 5 into 3 into 3 into 2, which would be 90. So 36/90.
Wait. Okay, sorry, I just lost it. What were you saying? 36/90. Is that what you said?
Yes.
But 36/90, how will it be equal to 1/3?
So it won't.
Yeah. See, look, what I think we can do is, first let us find out, okay, first let us find out the factors which are even numbers. Okay. Now, do you people agree that if we subtract the number of odd factors, okay, if we subtract the number of odd factors, then we will get from 108, then we will get the total number of even factors. So we can do that. Okay. Even factors. Okay. Number of even factors is 108 minus number of odd factors. Now look, for odd factors, it has to be 332, because otherwise the moment one power of this 2 comes, then all of them will become even. तो यहाँ पे when we go to the general form, okay, when we go to the general form and try to write it for odd factors, m1 का value fixed है and that value will be 0. The moment it becomes greater than 0, वो even हो जाएगा. तो m2 m3 m4 का तो कोई दिक्कत नहीं है ना, करेक्ट? m2 m3 m4 का कोई प्रॉब्लम नहीं है. So how many such factors are there? 18. Do you agree? Yes.
Yes, sir.
हाँ. तो कितने इवन हो गए? 90. ओके, 90. ओके, 90 इवन फैक्टर्स है. अब इनमें से ऐसे कितने फैक्टर्स है जो डिविजिबल बाय 4 नहीं है? कैसे निकालेंगे? Yes, please.
Sir, we'll use complement method again. How much is divisible by 4? Plus
How many
complement.
are divisible by 4?
Yes, sir.
नहीं, मुझे नहीं लगता उसकी कोई ज़रूरत है.
So we have already found out how many will be divisible by 4 because to be divisible by 4 the number has to be even, so there won't be any difference in that.
करेक्ट. तो नॉट डिविजिबल बाय 4 है 36, है ना? एंड ऑल ऑफ देम बिलोंग टू इवन नंबर्स. ओह वेट. नहीं, एक मिनट आनेगा. सी, इवन फैक्टर्स चाहिए हमें, लेकिन डिविजिबल बाय 4 नहीं चाहिए. अभी देखो, जस्ट वेट. हाँ, नंबर ऑफ इवन फैक्टर्स इज 90. तो इसमें दो कैटेगरीज है. एक डिविजिबल बाय 4 है और एक नॉट डिविजिबल बाय 4. अब डिविजिबल बाय 4 होने के लिए, और अदर नॉट डिविजिबल बाय 4 होने के लिए 2 रेस टू क्या होना चाहिए? 1 होना चाहिए, है ना? 0 नहीं हो सकता वहाँ पे, क्योंकि इवन का कंडीशन डाला है हमने. डू यू अग्री? So 2 raised to 1 will be there, and then for 3, 5 and 11 no restrictions. Correct? समझा? M2 M3 M4 पे कोई restriction नहीं है, तो ये भी 18 ही हो गया. Yes, no, or not getting?
Yes, sir.
Yes, sir.
Understood. तो कितना
Yes.
हो गया? Probability not divisible by 4 under the condition that it is an even number not divisible by 4 है 18 such factors. इनमें odd factors का inclusion नहीं है. अगर करते तो वो 36 हो जाता, है ना? Yes. Even number is 90.
So we can also do this that if we just subtract the number of even factors that we found, which
हाँ.
would be 108 minus 36.
No.
From
108 minus 18.
no, in the total, uh,
So
including of the odd numbers.
no, including what are you saying? In that list, include odd numbers
If
and
we include, if we take all the numbers and subtract the 36 numbers that are not divisible by 4 but even, wait, what's that?
see. I
Can
think
you show the upper part of the solution?
still okay. हाँ.
So, in this 36 is the number of uh, 36 is the number of the uh, devices that are not divisible by 4.
Not divisible by 4. Okay.
So if we subtract that from 108,
Hmm.
we get the factors that are divisible by 4.
Yes.
So if we subtract that number from 90, we get the even factors that are not divisible by 4, which would be 18.
Mm, okay. So acha, first question. So you are getting 18 by 90 as the answer, right? As far
So
as
now,
no, as far as I see it, you are trying to write 108 as sum of three numbers, and in that you are considering the number of odd factors, then even factors not divisible by 4, and then even divisible by 4. Is that what you're saying?
So I'm writing it as a sum of numbers not divisible by 4
Hmm.
and numbers divisible by 4 first. And all the since all the
Okay,
numbers
so you are
divisible
saying
by 4 are,
divisible by 4 and not divisible by 4, है ना?
yes,
ओके एंड देन नॉट डिविजिबल बाय 4 में दो कैटेगरीज है, ऑड भी हो सकता है या इवन हो सकता है, लेकिन 4 का मल्टीपल नहीं.
yes, sir, but the numbers that are divisible by 4, they will always be even.
Hmm.
So first, if we write it as a sum of the numbers not divisible by 4 and the numbers divisible by 4, we can easily find the number of numbers that are divisible by 4.
हाँ बट हमारे पास तो
That would be
एक्सप्लिसिट.
108. That would be 108 minus 36, which would be 72.
ओके.
So we know that there are 72 numbers that are divisible by 4. Now, if we write the number of even numbers that are divisors, we can write it as 72 plus the numbers that are not divisible by 4.
ओके वेट, जस्ट यू राइट डाउन वॉट एवर यू आर सेइंग एंड यू सेंड इट टू मी. वर्क्स.
Oops.
Yeah. Okay, my suggestion was, because the number that we chose, 108, as in total number of factors, is a small number. So what we could do was, instead of applying the PA given B equal to PA intersection B upon PB, we can directly go for NA intersection B upon NB, and that's what we have done here. We have first found out how many even factors are there, and it turned out to be 90, and among them we found out the factors which are not divisible by 4, because if a factor is even, वो either divisible by 4 होगा या divisible by 4 नहीं होगा. Okay, and then it was 18, so 18 upon 90. ठीक है. Okay. Now we'll go to question 4. Nabil, why so late?
I got up a little late today.
Sorry?
I got up a little late today for the issue.
Okay. A pair of positive integers m comma n is said to be a happy pair. I can give any name here. If GCD of them is a perfect square. Suppose k is a positive integer such that 205800, that is 2,05,835k, is a happy pair. Then the number of positive values of k with k less than or equal to 2940 is 27, 36, 30, 28. This is from NEST 21 first shift question 5. Acha. So we are given two integers, two natural numbers of course, and when the GCD of them, okay, is a square of some natural number, okay, then or in other words, they have no common factors, other factor apart from r squared. Well, of course r will then become a common factor, but well, when we consider the GCD, greatest common divisor, that means that's going to be r squared. Okay, so no factor exists, common factor exists greater than r squared. Okay. Now they are saying that 205800 and 35k is a happy pair. मतलब इन दोनों का greatest common divisor है कोई perfect square. Got it? And then they are restricting k to 2940. Okay, they are restricting k to 2940, and you are asked to find out how many k values can exist. Okay. Okay. Now notice here, 35k will always be divisible by 35. Goes without saying. And
Would it be feasible to write the prime factors for 205,800?
No, feasible no, that is वही करना है हम लोगों को अभी. Correct? We will do that. Okay. So first of all, अच्छा एक मिनट मैं इसको नीचे लेता हूँ. So I'll start with 100 and then I will divide it by 2. So it will be 1029. Now 100 is 25 into 4 है ना. 100 is 25 into 4 और वो 4 जो है वो इस 2 में इंक्लूड कर दो तो 2 क्यूब हो गया. 1029. Sum is 12 divisible by 3. Great. So this happens to be cube now. Okay. Acha. So have you people understood this part? I mean, there's nothing to be understood here. Also note that if we go for 2940, okay, 2940, it is divisible by 10. Okay. Okay, so this also is divisible by 3. Ooh, okay. So this is actually divisible by 7 else also. It's 49 into 2. So it's 2 squared into 3 into 5 into 7 squared. Okay, 2940. So how many factors does it have common with 205800? It has 2 squared, 3, 5 and 7 squared. ठीक है, let it be. But our main focus will be on these two numbers. Okay, our main focus will be on these two numbers. Look, to begin with, what we will do, we will write down the factors of 2,05,800 which are perfect squares. Okay, perfect square factors of perfect square factors of 2,05,800. Acha. So can you people start telling me perfect square factors? 1, okay, 2. Now see, 2 raised to 4 की कोई possibility नहीं है क्योंकि यहाँ पे 2 क्यूब पर ही वो रुक रहा है ना. 5 squared and 7 squared. Okay. Will there be any other factors apart from these?
If we're talking about, if we're including like a composite factor, we could have like
7
5 square
into 5 plus square.
Yes, 10 का स्क्वायर चल जाएगा, फिर 14 का स्क्वायर चलेगा, फिर 35 का स्क्वायर भी चलेगा. Correct? And the largest square factor of this number would be 2 squared, 5 squared, 7 squared. Have you followed this? Yes? Take 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 perfect square factors. Now let us return to this 35k. Okay, now let us return to 35k. Now look here, 1 can never be a GCD of these two numbers. Okay, because 35 is always a factor of 35k. Do you agree? 35 will always be a factor, so perfect square नहीं हो जाएगा वो. What about 2 squared? Again not possible. The moment you say that 2 squared is the GCD, I'll say no. 2 squared into 5 into 7 is also a factor, and it is in fact greater than that. Okay, and we can actually apply this logic and rule out 5 squared and rule out 7 squared as well. बिकॉज अगर आप कहोगे कि सिर्फ 5 स्क्वायर्ड ही GCD है तो 5 स्क्वायर्ड इंटू 7 का क्या? अगर आप कहोगे कि सिर्फ 7 स्क्वायर्ड ही GCD है तो 7 स्क्वायर्ड इंटू 5 का क्या? गॉट इट? I mean, it will be a factor, but it will not be the greatest one, so we cannot call it GCD. Raise your hands if you have followed this approach or this argument that we are making. Everyone? Okay. Okay. तो अभी ये इंडिविजुअल तो नहीं हो जाएंगे. Let's think about 2 squared 5 squared. Will this be possible? No, because if you say 2 squared 5 squared is our GCD, I'll say 2 squared 5 squared into 7 फैक्टर है. Got it? 7 का कोई रोल नहीं है वहाँ पर, तो ये नहीं है. ठीक है. How about 2 squared 7 squared? Will the same argument work for 2 squared 7 squared as well? Yes. आप कहोगे 4 into 49 फैक्टर GCD है. मैं कहूँगा 4 into 49 into 5 भी है, क्योंकि 5 is always going to be a factor of 35 into k and 2,05,800. So we are left with 2 more possibilities. अभी चेक करेंगे कि इनमें से कोई हो सकता है कि एक ही रहा तो हमारा काम कम हो जाएगा. Now is 5 squared 7 squared a possibility? Yes, no?
Yes sir.
Yes, ये possibility है. क्यों है? अभी तो लग रहा है कि 5 squared 7 squared ये obviously 35k का फैक्टर हो सकता है. अगर k को 35 ही ले ले तो पॉसिबल है k को 35 लेना, क्योंकि k is less than 2940. And how about this? Do people agree or disagree that this should be included in the list? ये कर सकते हैं क्या include?
Yes sir.
कर सकते हैं. कैसे कर सकते हैं? क्यों?
8 में 8 फैक्टर आ जाएंगे.
सॉरी,
सर ये वो मतलब
हाँ
में फैक्टर आ जाएंगे 2 के.
हाँ आ सकते. करेक्ट. ठीक है. सो based on the data we have arrived at the conclusions that if 2,05,800 and 35k have only a square, perfect square as their GCD, okay, as their GCD, that GCD has to be either square of 35 or square of 70. Agreed? Yes, no?
Yes, sir.
Yes. So let us now start with 35k being 5 squared 7 squared into उसको अभी हम L बोल देंगे. ठीक है. Now look, 35k already has a specific form 5 into 7 into k, and because k is less than or equal to 2940, okay, can I say that L will be less than or equal to 2940 upon 35? क्यों 35 आ गया यहाँ पे? Because 5 squared 7 squared is being considered, okay, and out of 5 squared 7 squared 5 into 7 is already there into k. तो L जो है हमारा वो 2940 upon 35 हो जाएगा और या उससे कम. ठीक है. अभी let me allow me to use calculator here. 84 आ गया. Okay, 84. L is less than or equal to 84. Have you followed this? L less than or equal to 84. Okay. Now we also should pay attention to the fact that L cannot be divisible by 2, 3, 5 and 7. Agreed? because it cannot be divisible by 2, 3, 5 and 7. See, why can it not be? It can be divisible because 84 से कम है, but the moment you say it is divisible by 2, the GCD shifts from 5 squared 7 squared to 5 squared 7 squared into 2. Understood? Because our number already has a lot of powers of 2. It has 3 powers of 2 here. Got it? It also cannot be divisible by 3, our L, because if were divisible by 3, GCD will shift from 25 into 49 to 25 into 49 into 3, which is no longer a perfect square. Okay? 5 और 7 का similarly argue कर सकते हैं, तो वो भी नहीं आएगा. So what we will do is we'll start writing down the prime numbers now. Okay, prime numbers and possibly their multiples greater than 7. I think that basically will be greater than or equal to 121, and that's less than greater than 84. So just prime numbers writing is enough. Okay, so L belongs to. Okay, let us also not miss the number 1, right? Because 1 is the least 35k, right? 35. Okay, least k, not least. Got it? So 1 हो गया. The next prime number is 11, then 13, then 17, then 19. Okay, tell me if I miss any prime number. Then 23, 29, 31, 37, 41, 43, 41, 43, 47, 53, 59, 61, 53 नहीं है, 67, 71, 73, 79, 80. Okay. 1 2 3 4 5 6 7 8 9 10 11 12 13 Okay, so there are 20 values of L. Now see, if you take any multiples, okay, so for all, let me say L1 L2 belonging to, let me say L minus 1, L1 into L2 is greater than 84. तो वो हम नहीं लिख रहे हैं. This point is important. ये समझ में आ गया क्या? Yes? No? See, अगर हम लोग को यही कंडीशन लगानी है, L cannot be divisible by 2, 3, 5, 7, तो हम 11 into 13 भी लिख सकते हैं ना. वो भी डिविजिबल नहीं है 2, 3, 5, 7 से. लेकिन हमारा जो ये 11 into 3, 13 ये नंबर है, ये 84 से बड़ा है, तो इसलिए वो इस लिस्ट में नहीं आएगा. गॉट इट? बिकॉज वी हैव ऑलरेडी इम्पोज्ड दिस कंडीशन. अगर हम कोई ऐसा कंडीशन हमें मिलता कि भाई L 200 से कम है, तो फिर L1 into L2 का नंबर हमें लेना पड़ता. हैव यू फॉलोड दिस?
Yes, sir.
ठीक है. So we have now completed almost 50% of the problem, because we have now written down those numbers, or as in count, which share a square as a common factor, or the GCD, I would say GCD, but which are all odd numbers. None of them contains 4 as their factor. ठीक है, तो ये 20 हो गया. लेकिन हमारे जो भी ऑप्शंस है यहाँ पे, हमारे जो भी ऑप्शंस है वो सभी के सभी 20 से बड़े हैं. ठीक है, तो अभी हम लोगों को कौन सी पॉसिबिलिटी कंसिडर करनी चाहिए? ये दूसरा टिक जो है 2 स्क्वायर 5 स्क्वायर 7 स्क्वायर, ये पॉसिबिलिटी कंसिडर करनी चाहिए. ओके, 2 स्क्वायर 5 स्क्वायर 7 स्क्वायर की पॉसिबिलिटी कंसिडर करनी चाहिए. ओके, डू यू अग्री टू दिस? 2 squared, 5 squared, 7 squared possibility should be considered now? Yes?
Yes.
Okay. Acha. And for reference, let us also go back and write down the factorization, the prime factorization of this number. Okay. ठीक है. तो अभी हम हमारा जो 35k है, 35k, उसका जनरल फॉर्म क्या हो सकता है? 2 स्क्वायर्ड, 5 स्क्वायर्ड, 7 स्क्वायर्ड m हो सकता है ना? 2 स्क्वायर्ड, 5 स्क्वायर्ड, 7 स्क्वायर्ड l m. अब देखिए कंडीशन क्या थी उस k की? k लेस देन और इक्वल टू 2940 था, है ना? k was less than or equal to 2940. इसका मतलब हमारा जो m है वो किससे कम हो जाएगा? uh, 35 ये है ना, तो 4 into 5 into 7. Please raise your hands if you understand that. Okay. तो इसको अभी 4 से डिवाइड कर देंगे, 21 है वो, है ना? 2940 upon 35 was 84 and if you further divide it by 4 it became 21. ठीक है? All right. Okay. So now what we would like to look for is, we would like to look for those numbers less than or equal to 21 and not equal to, okay, not equal to 257, let's see, okay, and which meet the requirement. ठीक है. Raise your hands if you agree that 1 will belong to this. हमेशा, क्योंकि m तो सबसे छोटा हो गया वो, है ना? GCD का वो मल्टीपल ही हो गया. ओके. अच्छा. Is 2 possible? No, 2 is not possible क्योंकि इसमें 2 3 है. 3 possible है क्या? नहीं, इसमें 3 फैक्टर है. अभी सबसे इम्पोर्टेंट चीज़, कैन आई पुट m as 5? थिंक अबाउट इट.
यस सर.
वाई?
सर बिकॉज उस नंबर के पास 5 के और फैक्टर नहीं है जो कॉमन लिए जाए.
एग्जैक्टली, गुड पॉइंट. यहाँ पे जो है ना, ये 25 से ऊपर इसका कोई फैक्टर नहीं है जो 5 का पावर हो, तो इसलिए हम यहाँ पे 5 ले सकते हैं. 7 नहीं ले सकते, राइट? बिकॉज यहाँ पे 7 क्यूब है. 9 ले सकते हैं क्या? फॉरगेट अबाउट इट. 9 क्योंकि 3 है यहाँ पे, तो 9 नहीं ले सकते. ठीक है, तो 11 लिखेंगे अभी, 13 लिखेंगे. ओके, 13, देन व्हाट? 11, 13, 17, 17, 19. So how many are there? 6 factors will be there. ओके, तो L का हो गया 20 और ये M का हो गया 6. तो अभी हमारा टोटल 20 से ऊपर जाके 26 हो गया, लेकिन वो भी इन ऑप्शंस में नहीं है. तो अभी हम लोग कुछ चीज़ें मिस कर रहे हैं क्या, उसके बारे में सोचेंगे. आर वी मिसिंग आउट एनीथिंग? आर वी मिसिंग आउट एनीथिंग? 20 वैल्यूज़ L हो गए, 35k है, 2 स्क्वायर, 5 स्क्वायर, 7 स्क्वायर इंटू m, 21. ओके. Yes, looks like we missing out some values. Let's figure out that now. Two squared, 5 squared, 7 squared into m. 25k is that k का सही है ना 2940 कंडीशन. ओके k 2940 से कम है तो 20 है ना. 1 5 11 13 17. Can any multiples of 5 come there? No, right? No, if I take 25 for instance. Okay, if I take 25 for instance, is it exceeding our number? Okay, wait. So let us write this number here. Okay, and let's go to 35 into the largest allowed k. वो exceed हो रहा है ना. One lakh 2000 हो रहा है. Okay. But definitely we are missing out some factors. Can you people recognize them? 2 squared, 5 squared, 7 squared into m. We cannot consider multiples of 4, right? Because otherwise it would become divisible by 8 also, and 8 is not a perfect square. And we can also not consider 3 there, or can we consider 3? No, 3 भी नहीं consider कर सकते वहाँ पे. Okay, just one second. भास्कर एवढी दार पुढे कर ना. Okay. 2 square. Okay, 2, 3, 7 are the additional factors. Apart from them, any other number can come. $25 तो नहीं है उसका. What other things can go there? 2 नहीं आ सकता, 3 नहीं आ सकता, 7 भी नहीं आ सकता, 5 आ सकता है. 25 will not be there, right? Yes, 25 won't be there. And just for the sake of it, if we take it as, I think we did that, 4 into 25 into 7 into 25, it is x. Oh wait. Oh sorry, 49. Yes, this is exceeding our number, right? Yes, okay, we did that. Okay, so our answer is not matching with their answer. Okay, our answer is 26. तो हम लोग कम से कम एक फैक्टर तो मिस कर रहे हैं. कैन यू पीपल स्पॉट दैट फैक्टर विच वी आर मिसिंग आउट?
So what's the answer in the official answer?
In the official answer key it is 30. Let me check. 2115. Yes, in the official answer key the option is C. So we are missing out 4 more factors. What possibly could those 4 factors be? We'll spend 1 or 2 more minutes on this, otherwise we'll go to next question. Perfect square factors. See, because of this 21 we cannot go beyond that, right? Wait. Can we take it as 20? Wait, will 20 work here? Yes? No, but 20 will not work because it's 8. Okay, 8 will also then become a factor. So GCT will not. ठीक है, we'll leave this here. I will send you the solution. I have it actually. Let's see. Multiples of 5 co-prime with 2, 3, 7. That means they are multiples of 5 but they are not divisible by 2, 3 and 7. So they happen to be 5, 25, 55 and 65. Let's try to justify this claim. Okay, 5, 25, 55 and 65. पहले कैटेगरी में है वो, मतलब ये वाले. ओके, 5 स्क्वायर्ड 7 स्क्वायर्ड इंटू एल. करेक्ट, हमने यहाँ पे सिर्फ प्राइम्स कंसिडर किए थे, लेकिन 29 मतलब हमारा जो दिया गया हुआ नंबर है 20500, उसमें 5 स्क्वायर्ड ही है. तो यहाँ पे 5 के वो फैक्टर्स भी चलेंगे एल के लिए, हमारे एल के लिए जो 2357 से फर्दर डिविजिबल नहीं है. ठीक है, तो या इसको ये मैं स्टार करता हूँ क्योंकि 25 चल जाएगा हमें, और अगर 25 चलेगा 5 भी चलेगा क्योंकि 205800 does not have 5 raised to x greater than or equal to 3 as its factor. Correct? It doesn't have 5 raised to x but x is greater than or equal to 3 as its factor. उसको 5 के 2 ही फैक्टर्स है उसमें, है ना. तो हम लोग फिर से उसके मल्टीपल्स ले सकते हैं बाकी के प्राइम्स के साथ. ओके, तो 5 हो गया, 25 हो गया, 55 हो गया 11 के साथ, 65 हो गया 13 के साथ, और अगर मैं 5 लेता हूँ तो वो 95 हो जाएगा, तो वो 84 से बड़ा है. तो ये 4 मिला के 20 + 6 + 4 30 हो जाएंगे. ओके, so that makes it 30. Option C. Spend some time with this because firstly we people are not used to solving such problems, क्योंकि हम GCD LCM ज़्यादा उसके बारे में पढ़ते नहीं हैं, है ना. लेकिन अभी नेक्स्ट में पूछते हैं तो हमको थोड़ा रेडी रहना चाहिए उसके बारे में. और सी इट ऑल बॉइल्स डाउन टू हाउ वी आर्ग्यू अबाउट एक्सक्लूडिंग पॉसिबिलिटीज़ एंड इंक्लूडिंग पॉसिबिलिटीज़. वी ऑलमोस्ट रीच दैट but we missed out one possibility out of the 3. Okay, we considered the 2 possibilities which exclusively contained prime numbers and 1, but we missed out that part where a composite number could be a factor, but still the GCD being square or that condition was maintained. Okay, so that's it with this. Are you guys okay with one more question on this, or let's go to geometry? You tell me.
Could do one more, yeah.
Okay, fine. So let's do this problem now. 15th.
Also, sir,
Huh.
I have seen what I was saying for the
Previous
question.
problem.
No, I'm saying I have sent you what I was saying for the previous problem.
Oh, you have sent me. Okay, okay. I'll go through it. Acha. From next 15. Let P and Q be distinct primes. So not same. Then the number of positive integer solutions of the equation 1 upon x plus 1 upon y equal to 1 upon pq is 3, 4, 8, 9. Now, in this sum, there is a particular way of approaching it, which I have found out, and that will take you to the solution. I also have one more approach in mind, but I'm not sure whether it will work. Okay, so let us start with our first approach. Okay, so this approach one makes use of the fact that if we have 1 upon a plus 1 upon b equal to 1 upon c, where a, b, c are all positive, okay, a, b, c are all positive, then we must have a greater than c and b greater than c. Do you agree to this? Like larger the number,
Yes,
smaller
sir.
will be the reciprocal. Got it? So this allows us to write x greater than pq and y greater than pq. Okay, x greater than pq and y greater than pq. So we can assume x to be, okay, pq plus d, and we can assume y to be pq plus e. Okay, and now we can go back to the given equation and put it here. So we will get 1 upon pq plus d plus 1 upon pq plus e equals 1 upon pq. That means the problem of finding x and y has now got simplified to the problem of finding d and e. Okay, so what can we do now? We can cross multiply. So pq plus e plus pq plus d into pq is equal to pq plus d pq plus e. Okay, so p squared q squared plus pqe plus p squared q squared plus pqd is equal to p squared q squared plus pqe plus pqd plus de. ठीक है, तो अभी ये कैंसिल होगा, pqe भी कैंसिल होगा, pqd भी कैंसिल होगा, and you will be left with de equal to p squared q squared. Okay, now remember d comma e is an ordered pair. Okay, d comma e is an ordered pair. So what we can say is if we consider the total number of factors that p and p squared q squared has, that will be our answer. Got it? Let me explain. Look, we have already said that if our number, okay, there was that probability inclusion problem where we were discussing that. Yeah, so the total number of factors, how we found it out. Okay, we considered the power of every prime number involved in that particular number, and we increased that power by 1, and then we took the product of the increased powers, and that gave us the total number of divisors. Got it? So if we apply that logic here, if we apply that logic here, then we can say that p squared q squared has 9 factors. How 9? 3 into 3. One corresponds to p squared, the other corresponds to q squared. 2 plus 1, 2 plus 1. Okay, so if it has 9 factors, okay, if it has 9 factors, it means 9 ordered pairs exist. Okay, so this is this sorry, so this gives us option D. Now the other approach that I thought of doing is this. I'm not sure whether this will work, because it just occurred to me we can also use this. Now because this solution happens to be independent of the choice of p and q, what we can do is we can select two prime numbers of our choice, and we can start ideally with 2 and 3. Okay, we can start with 2 and 3. So let's consider p as 2 and let's consider q as 3. So we are now looking for integer solutions of 1 upon x plus 1 upon y equal to 1 upon 6. Okay, we are now looking for this particular equation, and we need to find x and y here. Okay, now let's cross multiply. So x plus y by xy equals 1 upon 6. So 6x plus 6y equals xy. Okay. So we are now in search of ordered pairs xy where product is 6 times the sum. Product is 6 times the sum. Okay, but only one condition is there and two unknowns are there, so it's a bit difficult. Product is 6 times the sum. Yeah, now the problem is we cannot really apply trial and error because there is no limit here. There is nothing stopping that. Or can we consider it? Can we use arithmetic mean, geometric mean inequality here? Okay, let's say if we divide it by 2, so it will become 6 into x plus y by 2. Sorry, no, yeah, okay, divide by 2 becomes xy by 2. Okay, now what do we know? We know that x plus y by 2 is greater than or equal to root xy. Correct? Arithmetic mean is always greater than or equal to geometric mean. Suppose we square both sides. Suppose we square both sides, then we will get this, and we can look we can now have x plus y replaced by xy by 6. we can have x plus y replaced by xy by 6. So xy squared, okay, xy squared upon 36 into 4 greater than or equal to xy. Okay, xy will get cancelled. Okay, so we want xy to be greater than or equal to 36 into 4. I don't think we are getting anywhere. ठीक है, we will stop our discussion on this problem here. I thought this approach looks promising because of that involvement of AMGM inequality. You people can try that. Meanwhile, I'll also give it a look. ठीक है? Fine.
So we can find the number of factors of 36 into 4,
Yes, I had that
and
in
then
mind. Huh.
that divided by 2 would be the number of ways we can express it as x into y. So, and that is coming out to be 9. I just write that.
No, but how will you answer the question? So you considered the equality, right?
Yes.
So now we have to argue why the inequality is not applicable. मतलब अगर हम एक्स वाई इक्वल टू 36 इंटू 4 लेते हैं तो जो आप कह रहे हैं वो सही है. गॉट इट. You considered equality but you ignored inequality, right?
Right.
But in a way that might do it, because look, our see, the greatest available option is 9. So if you're getting it as 9, I think we are done, right? If you take 36 into 4, तो इसका प्राइम फैक्टराइजेशन कितना हो जाएगा?
2 raised to 5 into 3 square.
2 रेज टू 5 कैसे है रे? 2 रेज टू 4 ना, इंटू 3 स्क्वायर, करेक्ट? Yes, okay, 144. So how many factors does it have?
5 into 3.
15 factors it has, out of which one is perfect square. तो इससे 8 आ रहा है ना? Oh, okay, wait, nice. So out of this 15, one is perfect square, rather one is root of that. Okay, one is root of this, and then एक चला गया तो बचते हैं 14. तो अकॉर्डिंग टू यू उनको हम लोग नहीं, अगर 14 फैक्टर्स है उनके तो दो दो को कंबाइन करके ऑर्डर पेयर है ना, तो वो 14 ही रहेगा उस. या ठीक है. ठीक है, क्या करना है ज्योमेट्री का? सॉल्यूशन सेंड कर दूं क्या तुम लोग को, क्योंकि हम थोड़ा टाइम के बाहर चल रहा है. व्हाट डू यू सजेस्ट? Shall I send you the solutions, or let me keep this sheet एज इट इज़ ब्लैंक शीट. इनमें से जितने भी आपको आ रहे हैं आप सॉल्व कीजिए, और जो नहीं आया वो मैं आपको बताऊंगा. चलेगा क्या? यस, विल इट?
Yes. Yes.
ठीक है. इसमें जो एक प्रॉब्लम है यहाँ पे, ये मैंने ऑलरेडी सॉल्व किया है, इसका सॉल्यूशन यूट्यूब पे अवेलेबल है. लेकिन मेरा अप्रोच थोड़ा लेंदी है जिसमें कैलकुलस भी इन्वॉल्व है, तो मैं शिफ्ट ऑफ ओरिजिन यूज़ करके उसको सॉल्व कर किया मैंने वहाँ पे. अगर आपके पास उससे भी बेहतर अप्रोच है जो जल्दी आंसर निकाल सके, आप उससे भी कर सकते हो. बाकी के प्रॉब्लम्स में ज़्यादा ये है नहीं. इसके लिए आपको हेरेंस फार्मूला लगेगा, मतलब मेरा जो अप्रोच है उसमें, इसमें आपको हेरेंस फार्मूला लगेगा वो एरिया ऑफ ट्रायंगल का. फिर कैलकुलेटर का यूज़ करके आप उसका रेंज निकाल सकते हो. मतलब ये सब डिसजॉइंट है, 50, 66, 70, 78, 89. ठीक है. और बाकी के दो तो इजी है, ट्राई करो, पक्का आएंगे आपको. ठीक है. ये साइन रूल पर बेस्ड है. Cool. Another, were you not there when we solved complex numbers MCQs from Nest? You were there, right?
Sir, I don't remember solving them. I might have.
Huh, because we do have, and we have solved them.
Yes, sir.
On what?
एक
With
मिनट,
which
एक
chapters?
एक मिनट, एक मिनट. टू check 30-second lecture. Okay.
So that was in the IIT crash course. Sir.
Yeah, but PYQs were from Nest.
Okay.
I think there are two lectures on complex numbers. One is 32, which was conducted on 24th of May, and then 27th of May we conducted another lecture, and I think this was exclusively. But still, there are a few more MCQs which I had planned actually for today, but that one single problem took a lot of time. तो मैं वो भी आपको शीट आप अपलोड कर देता हूँ, आप देख लेना एक बार. इसमें 4 प्रॉब्लम्स है कॉम्प्लेक्स के, जो हमने जो पहले किए थे उसके अलावा ये प्रॉब्लम्स है. ठीक है. तो ये ट्राई करो, अगर नहीं आए तो हम कल उसको सॉल्व करेंगे, या मैं सॉल्यूशन भेज देता हूँ आपको. ठीक है.
Yes, sir.
या इसमें से ये फोर्थ है ना, ये थोड़ा मुश्किल है, आप ट्राई करना. ठीक है. तो कल जो भी फिज़िक्स के बचे हुए टॉपिक्स है ना, जैसे ऑप्टिक्स हमारा बचा है, और क्या क्या बचा है, apart from optics is there anything remaining like you want me to take those questions?
So thermophysics.
और हाँ, करेक्ट 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 करेक्ट, राइट राइट. काइनेटिक थ्योरी वो सब भी बचा है. एक मिनट, मैं सिर्फ नोट करके लेता हूँ.
Have you done wave motion?
Just 1 second.
Okay.
Okay. Optics, then thermodynamics, sound, yes, and wave motion.
Sir, in waves, can you please include some questions related to reflection of waves?
Okay. Reflection of waves. Okay. What else? So optics is there, thermodynamics is there, sound and wave motion is there. Is there anything else that we are missing out? आई डोंट थिंक सो. एक बार सिलेबस चेक कर लेते हैं. यूनिट्स एंड डायमेंशंस पे चाहिए क्या?